Alright, today in this video we'll be discussing working out and doing some exercises on electrolysis. But before that, let's quickly have an overview of what electrolysis is. Alright, hold on. When you hear about electrolysis, two things should come to your mind. Two things should come to your mind. Electron and what? And lysis. So two things should come to your mind when you hear what electrolysis. Two things should come to your mind. Electron and lysis. Meaning that what we are using a stream of electron, alright? That's electricity, right? Or you say current. We are using what? Current to what? To break down. What lysis means to break. So we are using current to break down. That's what electrolysis means. So you are using electric current to break down or to decompose certain substances known as what? Electrolytes. Look at this setup. This is a typical electrolytic cell. So you have your electrolyte, a substance, right? You have a substance there. Of course, it should be a chemical substance, right? And then you have your substance connected to a terminal, this battery. Okay, this battery here is what supplies the current to decompose or to break down this electrolytes. So the setup, you have two things here. You have we have an electrolyte, all right. You also have you have a terminal here, all right, as a source of the electric current. So now the current enters enters and leaves this electrolyte through what you know as your electrode. These are your electrode, anode and cathode. Now the current comes in through the through the anode. Alright, the current is the direct current. It comes through the anode. It leaves through through the cathode. Know that, alright? So these two now are the electrode, alright, that are dipped into this electrolytes, and all of this forms the electrolytic cell. All right, good. So you need to note that electrons leave. All right, electrons leave through the anode and they come in through the cathode. So take note, electrons leave the electrolytes through the anode, and they come in through the cathode back. So take note of that, and also the more detail will be given in the class. So for the sake of this video, so we won't dwell much on that. Let's go further. Is there another thing we need to check here? Alright, so take note your loss here. Your anode is connected to the positive terminal of the battery. Take note of that. So the two electrodes here, something happens here. A reaction happens here. Alright? They are called complementary reactions. And so we have half cell reaction here. Alright? So the two reactions, alright, are complementary. So at the anode, we have the oxidation happening at the anode. Oxidation happens at what? At the anode. Oxidation. That's loss of electrons. Happens at what? At the anode. At the cathode, we have what? Reduction. Alright? So remember, I told you that electrons leave the electrolyte through the anode. So at the anode here, alright? At the anode here, the ions that are dissociated in the electrolytes, when they migrate to the anode, when current is passed through this electrolyte, the ions migrate, alright? So the anions migrate to the anode, and from there they lose electron. So it's called oxidation. At the cathode, cations migrate to the cathode, right? And then they gain electron and they get deposited. So deposition happens at the cathode, and what at the anode you can have what gas being liberated. All right. So please take note of those things. All right. So having known that, we'll solve questions soon. So let's quickly go through the laws of electrolysis. So the very first law we have the Faraday laws of electrolysis. All right. Faraday laws of what? Of electrolysis. Alright. Oxidation, don't forget, let me repeat this. Oxidation happens at anode, reduction happens at cathode. So that's that for that. Now let's go to Faraday laws of electrolysis. So we move to Faraday laws of electrolysis. The first law of Faraday states that the mass of the substance deposited during electrolysis is directly proportional to what? To the quantity of what? Of electricity passing through the electrolyte. So, like I told you before, right? We have substance deposited during electrolysis, alright, and it can happen at the cathode. At the cathode there, substance are deposited, alright. Now, the mass of the substance deposited, alright, is directly proportional to what? To the quantity of electricity passing through the electrolyte. So we have this. M is equal to ZQ. This Z there is what? Is the proportionality constant. Or you say the electrochemical equivalent is the constant, alright? So no, we use K in mathematics, but here you can use Z, alright? So remember, Q is IT. Q is the quantity of electricity, right? And it's equal to IT normally. Remember, so you can have M. Replace your Q with IT. You have what? M equals what? ZIT. Equation 1. Are you there? So the question can come in this form. What is the calculate the current passing through a substance of mass 5.0 of mass 50.0, all right, in no question can come in such way, and you have to find what? Find the current, all right, or you have to find it, or you have to find the time, or you have to find the mass. No, I was trying to find the question, but then I hope you get the point. So sometimes you have a question like that. So note this equation in your head. M equals to ZIT. You can also have it in this way. M over IT is equals to what? Z. Equation 2. Alright, take note of these two. Now, moving forward, there is a relationship between the Faraday, that is F, and what? And mole of electron. Alright? And mole of what? Of electron. 1 mole of electron requires 96,500 coulomb to pass through it. Let me repeat myself. Let me find the suitable way to put it. 1 mole of electron, all right. For you to have one mole of electron, you need what? 96,500 coulomb of electricity. So, and that simply means 1 mole of electron needs what? Needs 96,500 what? Coulombs. Now, 1 mole of electron therefore requires what? 1 F. Or will I say, yeah, I hope you get the point. 1 mole of electron what? Needs 1 F. So meaning that 1 Faraday is equal to 96,500. Do you get that now? So please take note of that. Take note of that. Now, another thing to note is that still under first law, there is a relationship between Faraday Alright, that is the quantity of electricity to pass through, and the mass mole relationship. Mass mole relationship. There's a relationship between the Faraday and what and the charge that the element or the substance carries. What do I mean? For univalent metal, like your Ag plus aqueous here plus E minus, giving you what? Ag solid. Now look at this now. This kind of substance, ion, alright, requires just one electron to be deposited as solid. This particular reaction happens at the cathode, because at cathode, alright, ions receives electron. This is an ion, it receives electron and gets deposited, alright, but at the anode they give electron. So here now we have Ag plus receiving what? Electron to be what? To be Ag as solid, alright, but then it requires just one electron, one mole of electron. So it's called an univalent metal because it's just what? One electron it needs. Do you understand? So as such, it will need one F, that's one Faraday. Requires what? One Faraday, because one E is equal to what? One F. So such substance to be deposited requires just one Faraday. So if I ask you now that what is the quantity of electricity required to deposit 1 mole of silver as shown in this equation, what you should tell, what I expect you to tell me is what is 96,500, because you just need 1 Faraday. That's 1 times 96,500, because 1 Faraday is what is 96,500. It's as simple as that. But for a divalent metal, like your copper, Cu2 plus aqueous plus 2E minus, give you what? Cu solid. Something like this now requires 2 electrons to be what? To be deposited as what? As copper. Alright? To be deposited. So from here now you should know that 1 mole of copper requires what? 2 electrons, or you say 2 charge. It's the same thing to be deposited. Now, if I now ask you what is the quantity of electricity required to deposit 1 mole of copper, what I expect you to tell me is what? 2 times F, that's 2 Faraday, and that will be 2 times what? 96,500, because 1 Faraday is what? 96,500, and so you have 2. So 2 times, and that will give you answer automatically. So these are questions we see in JAM. So I hope you understand the concept now. For a trivalent metal, like let's say for a trivalent metal, like your aluminium, Al3 plus aqueous plus what? Plus 3E minus, give you aluminum. So something like this now, to deposit 1 mole of aluminium, please take note, it is 1 mole of aluminium we are depositing. Alright, so to deposit 1 mole of aluminium here, we need what? 3 electron, that's 3 charge. Automatically that's what? 3 times F. Alright, so 3 F, and that's 3 times 3 times what? 96,500. So that's the quantity of electricity required to deposit 1 mole of what? of aluminum. So now we have understood that. There's another thing I want us to note, still on that first law. In the case of I want to link the relationship between the molar mass. Are you there? The molar mass, the mass, the charge, the Faraday. Want to bring everything together, to link everything as an equation that you can always use. All right. See, this one here, you can also go through this this pathway. You get to answer, but there's a shorter method. And so, if you know the relationship between the Faraday charge, number of mole, and the time and current, I think that will be more fast rather for a case like jam. So what do I mean? What do I mean? You already have your how do I put it now? From our Faraday law, the mass of the substance deposited during electrolysis is directly proportional to the quantity of electricity passing through the electrolyte. Now, that formula, that law holds, right? However, we can also, instead of using mass, we can also use our molar mass. Yes, because we can use our molar mass too instead of mass, because sometimes we deal with molar mass and not just mass alone. Alright, so when you want to introduce molar mass, now you have something like this. Molar mass is equals to what? Quantity of electricity, quantity of electricity passing through. Then your Z will be here. Z will be here. Now, your quantity of electricity depends not just on the Faraday, that is your coulomb. That's the quantity of the coulomb of how do I put it now? The Faraday, the electricity passing through the substance or the electrolyte. Your Q is not just dependent on that. Alright? We also need to factor in the place, we also need to consider our charge, the electron of that particular substance that is deposited. So we need to bring that in. So you have molar mass equals to Z. So we can call it, let's call that charge E. Alright, that's E. Then F. So I want you to take in that your Q is not just IT. Or let's say it's not just IT, yes. You can also have EF, because your Q is determined by Faraday, that's 3500, alright, and also the charge on the on the ion. So take note of that. So from there you can have M over EF equals to what? Z. Let's call this equation 3. When we equate this one and this one together, see, they're looking like each other. They're looking like each other, right? Let's equate them. So we can have EF equals to what? M over IT. Alright? So from here we can have, remember, this M here is the molar mass. This one here is the small m, is the mass. Okay? So we can now have, let's bring this one down. Let's have IT, let's cross multiply rather. Let's cross multiply. We have what? IT equals to mass over molar mass. Alright? Then Fe. This is what I did. This one here, I brought it up. Alright? This is it here. While this one here, I brought it here. This one I brought it down. So So you have mass of molar mass down. So IT is equals to what? Mass of molar mass is what? Is mole. N. So you can have IT equals what? FEN. Equation 4. So I want to believe we understand this concept very well now. How we started from here down to here and down to here. So the very, very simple concept. Make sure you understand this IT equals FEN. So I is current measured in what? In amperes. T is time measured in what? Measured in seconds. F is what? Faraday. Alright, measured in coulombs. Alright. And that's a constant value of 96,500. E is the what? Is the charge. The charge of what? Of the ion to be deposited. Alright. If the equivalent to be 1, if the divalent to be 2, if the trivalent to be 3. And the end here is just your mass per molar mass. Alright. So I want to believe you understand this. Alright. You can go over the video again and I trust you understand. So let's go to the second law of what? Of Faraday. Second law of Faraday. Now that states that when the same quantity of electricity, alright, is passed through different electrolytes. You have different electrolytes, alright, different electrolytes like this. And the same quantity of what? Of electricity is passed through all of them. Alright. Then it now states that the amount in mole, alright, the amount in mole of the element of the substance deposited is inversely proportional to the charge on the element. The amount in mole of the elements of the substance deposited, of elements deposited, is inversely proportional to the what? To the charge on that element. So from there we have this. From there we have what? We have this. N equals to what? K E. Alright, that's our constant, proportionality constant, right? Then you have NE. Alright, NE. So in the case where you are relating about two substances, alright, two elements. You have N1 E1 equals to N2 E2. Alright, like that. So this is Faraday's second law of electrolysis. Very, very simple. Very, very simple. So N is number of mole. E is what? E is the charge. Alright. Then that would be that. So we'll take questions now shortly and then we'll apply all of these things. Alright. So let's move to question now. So yeah.